Hi guys, today we're working on Unit 4, Section 1 over quadratics. And just so you know, here we have the standard form of a quadratic function. So we have ax squared plus bx plus c, where c is the constant. A cannot be 0, so that's why we have the restriction right there, because if a is 0, x squared goes away, so that will be bx plus c, and that's going to be a linear function. So in order for this to be in standard form, a cannot be 0. Okay, when we're graphing a quadratic function, it's x squared. And we know from previous units that it makes a parabola or a smiley face for the parent function. And we can get those points by substituting that into the function so we can get the y value. So when x is -3, well, -3 squared is 9. -2 squared is 4. -1 squared is 1, and so on. That's how I got these points. Now, on the graph, go ahead and plot them, and that's where I got the quadratic function right there on the graph, or the parabola. Now, I have the x-intercept. We only have one in this case. It intersects the x right there at 0, 0. It also intersects the y right there at 0, 0, or the origin. The axis of symmetry is the line. It's a vertical line that goes through the graph. Right there in the middle is where that line cuts your parabola in half. So it would be the axis of symmetry. It's right there. So you can barely see, but you get the idea. So the vertical line that cuts the parabola in half is called the axis of symmetry. Axis of symmetry. The vertex is this beautiful point right there, right there. Domain, we talked a lot about domain in range over Unit 1. So domain goes on forever, both ways on the x, from -infinity toward +infinity, or all real numbers. Now, the range for this parabola will be everything as long as it's greater than or equal to 0. So y starts right there, +infinity, and it goes down all the way down to 0. It doesn't pass 0. So for you to write either as inequality or as interval notation, that's what I have right there for you. So it's from 0, inclusive, up to +infinity, exclusive. The shape of the graph of the quadratic function is called a parabola. Okay, this is where it gets good. So I tried to color code everything until we get really used to the names here. Half of them you already know, but it's more like a review. So x-intercepts are the 2 points. Sometimes it's going to be 1 point. Sometimes you're not going to have an x-intercept. Are the 2 points where it crosses your x-axis. So your x-axis is right there. The 2 points right there, 1, 0, and 5, 0. The y-intercept is the point where the graph crosses the y-axis. So right there, 0, 5, that's right there in green. The axis of symmetry, we just talked about it on the previous page, is the vertical line. In this case, it's the line that cuts the parabola in half. So because it's a vertical line, it's going to be x equals, not a point, it's a line. So it's x equals 3 in this case. The vertex is that point right there, that point where it changes direction. So that point right there, 3, -4. Domain of any quadratic function will always be all real numbers, or from -infinity to +infinity, always. Range, if it's a positive parabola or upward opening parabola, it's going to go from that vertex up to +infinity. In this case, the y from the vertex, right there from -4 up to +infinity. So, and it's inclusive right there, -4. Okay, I try to be consistent with the colors. So I used yellow for all the x-intercepts. Right there, those are the points that cross the x. Green for y-intercept, that's the point that crosses the y-axis. The vertex is blue right there. Axis of symmetry, that's the line that cuts the parabola in half. And because it's a line, it has to be x equals. Axis of symmetry right there. What else do we have here? And all these points, I was able to pull them from the graph, except for this one that I simply substituted the -3 right there for x. So I did -3 squared minus 2 times -3 minus 3. So -3 squared is 9. -2 minus 3 is +6. So I have 9 plus 6 is 15. 15 minus 3 is 12. That's the end of page 2. Okay, so I have example 2. Now, this one is an upside down parabola. Okay, I still have the two x-intercepts, and I pull these points from the graph. Those points right there on the x-axis, right there. The one in blue is the vertex. The one in green is the y-intercept, the point where it crosses the y-axis. What else? And I pull these points from the graph. And again, this last one, I had to substitute that in the formula. So 3 right there for x and right there for x, and then you just math it out. Now, number 3, here you have the vertex and the x-intercept right there in the same point, because it only touches the x-axis once, and that's the point right there. So that's why I have two colors right there for the vertex and the x-intercept, and that's right there at -2, 0. The y-intercept is right there in green at 0, -4. And these points right there were not on the graph, so I had to substitute and plug that into the equation or the function to get me the output right there. And then the axis of symmetry, I have that x equals -2, that vertical line right there. Okay, one more. So in this one, you're going to look at all these things and you're like, okay, what's all that? So what I did here, I factored the 2 out because I know at this point I can divide everybody by 2. So I divided everybody by 2, and that's what I kept in parentheses right there. So this would be what we call the GCF. So the GCF is right there in the front, and then I divided 2x squared divided by 2, I put it there. -4x divided by 2, I put it there. -16 divided by 2, I put it there. Now I went on to factor this out. So the 2 doesn't disappear when you're factoring, but I factor this out by thinking, what are the two numbers that multiply to -8? Well, I think about -4 times 2 is -8. And the same two numbers that add up to the one in the middle, and the same two numbers that add up to -2. Well, -4 plus 2 equals -2. We're going to talk about factoring a lot coming up. Don't you worry. So what I was able to pull these points from the graph right there. And I know this is the vertex, this is the y-intercept. Try to do that on your own. And then you double check with mine right here. That's why I didn't color code anything. That's why I didn't label this. I want you to try that on your own. This one, you can plug in -3 in the original function or the factored function. I plugged it into the factored just because the math would be easier. But if you just want to plug that in right there, that's fine too. So which of the parabolas from questions 1 through 4 have a maximum and have a minimum? Well, the minimum value is when you have a parabola that looks like this. It goes down all the way to the minimum, like this one. And the maximum would look like a parabola that is upside down, like this one in this case. It's an upside down parabola. So you start in the bottom, you go all the way up to the top, and that's the maximum of the parabola. And then you go down. And it's always at the vertex. So maximum looks like this. Minimum looks like this. So minimum, examples 1 and 4, and maximum, examples 2 and 3. So if A, or the leading coefficient, is greater than 0, it's going to open up. It's going to look like this, and it's going to have a minimum. If A is negative or less than 0, then it's going to be an upside down parabola that looks like this. Leading coefficient less than 0 looks like this. Leading coefficient less than 0 looks like this. Okay? So when A is greater than 0, it opens up. When A is less than 0, it opens down. Based on this, we're only determining if it has a minimum or a maximum. So we're going to look at the leading coefficient. Leading coefficient is negative. If it's negative, it opens down. And parabolas that look like this, they have the maximum. So this one has a negative leading coefficient. So does this one. So they both have negative leading coefficient. They both open downward. That means they have a maximum. The other two, they have positive leading coefficient. That means they open upward. They both have the minimum. And I will make another video for the next page.